again, we are on Chapter 2, Section 1, Relations and Functions. The first thing we're going to do is define a couple terms. First, a relation, right now we'll consider this a set of ordered pairs. Our domain from before are x values. Our range are y values. Let's look at an example here. Given the following relation A, state the domain and the range. Okay, well my domain and my x values, so here are my x. So it's x comma y. So our domain, going to be 1, 3, -2, -4, and 5. Now typically if we would want to write this nicely, we would want to do it from the smallest number to the largest number in that ascending order. Okay, right now this is okay because we're just pulling out those x and y values. Now let's look at our range, our y's. 5, -2, 1, -3, and 1. So we did our domain and our range, given some ordered pairs there for that relation. If we look further down, we're given a graph, and we want to find the domain and range of each relation here, but this is done graphically. So first thing we actually need to do is figure out what these points are, so we're going to have to figure out what the ordered pair is. So this is -1, -2, -3, and then +1, +2. So this is -3, 2. And that one's going to be 4, -3. This one here is 2, 4, and that one there is 0, 1. So now when we have to do the domain, we see that we're just going to take those x values. So my x values, -3, 0, 2, and 4. And now my y values here are -3, 1, 2, and 4. All right, let's take a look at this next one over here. Doing the same thing. So we want to find all these points. 1, -6. We have 2, 1, 2, 3. We have -1, 1. We have -3, 1. -1, -2, and -1, -4. All right, we know what all of our x, y coordinates are for these points, so we can list the domain. A, -3, -1, 1, and 2. And our range, -6, -4, -2, 1, and 3. Now we see when we did these graphs, we did do those points, or those values from least to greatest numbers, all right? And that's how we would want to represent our answer for these. Let's take a look now at something a little bit different. All right, another way to show relation is to use a mapping diagram, which links the elements of the domain with the corresponding elements of the range. So we're given 4, 9 here. Again, we know these are x, y, and my x are my domain, my range and my y. So I'm going to put 4 here and 9 here. -6 here, 2 here, 5 here, and I don't have to list 9 because I already have 9 here. And then I have a 4. So now I'm going to map 4, 9. 4 goes to 9. -6 goes to 2. 5 goes to 9. And 3 goes to 4. Whoops, we forgot our 3 here. 3 goes to 4. So we see how all those get mapped there. We had to list our values 4, -6, 5, and 3. And then 9, 2. We already had 9 listed, and then 4 there. And then we just use arrows. take a look at our next one here. Same thing for mapping. -1, 3, -5. I don't need to list that 3. And then I'm going to do -2, 6, -10, and 2. All right, I'm going to draw arrows here. -1 goes to -2. 3 goes to 6. -5 goes to -10. And 3 also goes to 2. So we mapped that one as well. The next thing we're going to want to come across is we just talked about these being relations. Let's talk about function. Function is a relation such that each x value has only one value. Okay, so a function is a relation such that each x value has only one y value. This is where we say sometimes our x's can't repeat. Okay, x's can't repeat. If we happen to just scroll up here and look to see, our first one here, this is a function. We had y values that repeat, okay, but our x's did not. If we look at the one right below it, we did have x values that repeated, that 3 there, so this is not a function. All right, let's scroll down. We're going to do the same thing here. We want to do a mapping. So, do our mapping here. 1, 2, 3, 4, and 1, 2, 5. Okay. 1 goes to 1, 2 goes to 2, 3 goes to 5, 4 goes to 2. Okay, we see 2 goes to 2 and 4 goes to 2. That's okay because our y is repeated. Okay, so yes, this is a function. And if you look at our last one here, we have -1, -2, -1, and -2, 0, 2, and 3. We do our mapping for this. 1 goes to -2. And we have -2 goes to 0, -1 goes to 2, 1 goes to 3. We see here that -1 is going to both, that +1 is going to both that -2 and 3. So our x's do repeat here, so this is not a function. Okay, let's look at the next page. Graphing a relation on a coordinate plane gives you a visual way to determine whether it is a function. You can use, and this is called the vertical line test. As a refresher, vertical lines, okay, up and down, look at that. Going back to our chapter 1, they have an undefined slope. So if I look at this one here, I need to plot these points. I'm going to have -5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -5, -5. I have 0, 3, 0, -3. All right, well, I see here, if I draw a vertical line, I could hit both those points within the same vertical line, so that would be not a function. I could also draw another vertical line here, and it hits both those points, not a function. If it happens at any point on the graph, it is not a function. Okay, this just so happens it hits it twice. Let's take a look at this next one here. We have -4, 2, -2, 0, 4, 2, and 2, 4. If I were to draw some vertical lines here, I see, I could draw them anywhere on here. Anytime I draw a vertical line, it's only hitting the graph once. And we see, okay, it hits it once, doesn't hit it at all. If it hits it more than once, not a function. Okay, so if we want to just formally write this, this ended up being not a function. And we found out this was a function. Okay, we're going to use the vertical line test here to determine whether the graph represents a function or not. Okay? Well, look, I see right away. I'm going to draw a vertical line. It hits here, it hits here. It's more than once, not a function. So we're going to write no. Okay? If I were to draw, only once, only once, only once, only once. Anywhere along this graph, I see that it's only going to hit it once. So yes, this is a function. Now if I look at this one here, I can see it already going on the left. If I were to draw that vertical line here, it hits it twice. Not a function. So no. I could continue on with the graph, but once it hits it more than once, not a function. Some functions can be represented by equations. The following notation is used to represent a function described by an equation. We have y equals 2 of x plus 1. It can be written in the function notation as f of x equals 2x plus 1. That symbol, f of x, is written f of x and represents the value of the equation for a particular element of the domain. So if we look at this example, if f of x equals 2x plus 1, then f of 3 means find the value of the function where the value of x equals 3. The result can be also represented as an ordered pair. So if we're looking at this function, f of x equals 2x plus 1, all we're going to do is plug in that 3 where x is. So we get 2 times 3, and then plus 1 equals 7. So we can represent our answer. What we plugged in is our x. What we got as a result was our y. So 3, 7 is a member of the relation determined by this function. Now we want to find f of -3, f of 0, and f of 5 for each function on all of these. Alright, so what we're going to do, we're going to plug this in. We get 3 times -3 minus 5. We're going to wind up getting -9 minus 5, which is -14. I plug in my -3 here, and I get 3 times 4 times -3 minus 1, -9 fourths minus 1. I want common denominators, -9 fourths minus 4 over 4. It's going to give us -13 over 4. -1 fifth times -3 plus 3 fifths gives me negative times the negative is a positive, so I have 3 fifths plus 3 fifths, which gives me 6 fifths for this one. Now, some of them went over a little bit of the space. Let's see how we do here. F of 0. 3 times 0 minus 5. Anything times 0 is 0. Minus 5. So it gives me -5. Plugging 0 here. 3 fourths times 0 minus 1. So we get 0 minus 1, which equals -1. Plugging 0 here. -1 fifth times 0 plus 3 fifths. So we get 0 plus 3 fifths, which is 3 fifths. Alright, and our final one where we want to evaluate these functions at the given value. We're going to take 3 times 5 minus 5. Then we would get 3 fourths times 5 minus 1. And this one will be -1 fifth times 5 plus 3 fifths. Try to evaluate these three to see